Have you ever stopped to wonder how all the different apps and services you use every day just magically work together? Well, it's not magic. They're all speaking a hidden language, a language built with something called APIs. Today, we're going to pop open the Modern Developers Toolkit and see exactly how they talk.
I mean, think about it for a second. When you open your weather app, it's not like your phone has its own personal satellite floating up in space, right? Of course not. Instead, it just asks a big weather service, hey, what's the forecast for this location? That request and the answer it gets back is all handled by an API. It is the invisible plumbing of our entire digital world.
So, at its core, an API is just a set of rules, a contract, that lets two pieces of software talk to each other. The classic analogy, and honestly the best one, is a waiter at a restaurant. You don't just walk into the kitchen and start making your own food. That'd be chaos. You have a menu, you give your order to the waiter takes it to the kitchen, and then brings back exactly what you asked for. The API is that waiter. And just like a master chef has a whole rack of different knives and tools, developers have a whole toolkit of different APIs. So today, we're going to explore the workhorses, the power tools, and the real-time specialists that make everything you do online possible. All right, first up, let's open the main drawer of our toolkit. In here, we find the absolute workhorses of the internet, the two most established, most common tools for the job, REST and SOAP.
Think of these two like a couple of different wrenches. REST is kind of like a modern, lightweight, super flexible socket wrench. It uses the same standard web language, HTTP, that your browser uses right now, which makes it incredibly easy to work with and really versatile. SOAP, on the other hand, well, SOAP is like a big, heavy-duty industrial wrench from an older toolbox. It's a very strict protocol with its own rigid set of rules. It was built for absolute reliability, not for flexibility.
REST's simplicity is exactly why it became the king of the web for so long. It's just easy to understand and it scales beautifully. But it has one major nagging downside. You often get back way more data than you actually need. We call that overfetching. Or you have to make a bunch of different requests to get all the little pieces of data you want, and that's called underfetching. Now, SOAP, with its rigid, formal contract, doesn't really have that problem. And in super high-stakes environments, like, say, banking, that strictness is a feature, not a bug. You want your bank transfers to be rigid and reliable. The trade-off is pretty obvious, though. You get that rock-solid reliability, but it's way more complex, the messages are bulky, and it's just a lot slower. So those limitations with the old workhorses, well, they naturally led to innovation. So let's open the next drawer in our toolkit, the power tools. Say hello to GraphQL and gRPC. Two tools designed specifically to solve modern problems with some serious speed and precision. First up is GraphQL. This was actually developed by Facebook, and they created it for one specific reason, to fix that annoying overfetching problem with REST. So if REST is our trusty socket wrench, GraphQL is a precision laser cutter. It's a query language that lets the app on your phone tell the server exactly what pieces of data it wants. No more, no less. So for example, look at this. The app can ask for a user, but it specifies that it only wants the name and the email fields, and that's all the server sends back. Just those two things, not the user's address, or their birthday, or their entire comment history. It is incredibly efficient, especially for mobile apps that might be on a slow or spotty network. This efficiency is GraphQL's superpower. It completely solves both overfetching and underfetching in one elegant move. The main trade-off, as you can see, is that all this precision can make some things on the server, like caching, a little more complicated to handle. Okay, now let's talk about raw speed. For that, we have gRPC, which was built by Google. If GraphQL is the laser cutter, gRPC is the high-speed pneumatic nail gun of the toolkit. It's not really designed for public APIs that developers use for their apps. It's designed for the lightning-fast communication between a company's own internal services, what we call microservices. And it gets this incredible speed by using two key tricks. It uses something called protocol buffers, which are super compact binary messages, and it runs on HTTP/2, a way more efficient version of the web's main protocol. The performance gains you get with gRPC are just massive, but the trade-offs are pretty significant too. The messages are binary, so they aren't human-readable, which can make debugging a pain, and browser support is pretty limited. So this makes it the perfect tool for that high-speed chatter inside a company's own private network. Okay, let's close that drawer and open up the final one. Now, these tools are different. They aren't about an app asking a server for data. No, These are the specialists, tools designed for live, event-driven, and even peer-to-peer conversations. First up is the WebSocket. The best way to think about this is like a walkie-talkie. A normal web request is like making a phone call, saying one sentence, and then immediately hanging up. You have to redial for every single thing you want to say. A WebSocket, on the other hand, opens a persistent two-way channel. The line just stays open, so either the client or the server can start talking at any time, instantly. This is the magic behind basically any real-time application you've ever used. Think about live chat apps, collaborative documents like Google Docs, online gaming, those real-time stock tickers. They all rely on WebSockets to push updates from the server to your screen the very instant they happen. The only real downside? Keeping all those connections open can be a little heavy on the server's resources. Next, we have something called webhooks, which people often call a reverse API. The best analogy here is an old-school pager. Instead of you constantly calling the server, asking, anything new yet? How about now? Anything new? You just give the server your pager number. And the moment a specific event happens, like, say, a payment is successfully processed, the server pages you with the update. The flow is really straightforward. First, your application subscribes to an event on another service. Then, when that event finally happens, the service automatically sends a notification, a little message, right back to you. It's incredibly efficient for things like payment gateways or getting updates from your source code repository. So the huge benefit is efficiency. You're not wasting time and energy constantly checking for updates. The primary risk, though, is security. You have to be absolutely certain that any incoming notification is actually legitimate and is coming from the service you trust. And finally, we have WebRTC, which is basically the video phone of the API world. And this one is a real game changer. It allows two web browsers to connect directly to each other for audio, video, and data sharing, almost completely bypassing the server once the connection is made. And this direct peer-to-peer connection is exactly why browser-based video conferencing tools like Google Meets or a bunch of others work so well. The latency, the delay, is incredibly low because the video stream isn't going all the way up to a server in the cloud and then back down to the other person. The initial setup, which is called signaling, is a bit complex, but the payoff in performance and cost savings is just enormous. So, wow. We've filled our toolkit with workhorses, power tools, and some very cool real-time specialists. Now for the most important part, having the blueprint to choose the right tool for the right job. Because this is the question every single developer has to answer when they start a new project. With all of these amazing, powerful options on the table, how do you know which one is the perfect fit? Well, here it is. This is the blueprint, the ultimate cheat sheet for choosing the right tool. If you're building a standard public API for the world to use, you're going to stick with REST. For maximum, blazing fast internal speed between your own services, gRPC is the clear winner. If your mobile app needs to be super efficient with data, you choose GraphQL. And for any of those real-time features, you have your specialists, WebSockets for chat, webhooks for notifications, and WebRTC for video. It's all about matching the tool to the specific job you need to do. You know, when you look at this evolution from the heavy reliability of SOAP all the way to the peer-to-peer magic of WebRTC, you see that this toolkit is constantly growing and changing. It really leaves us with a fascinating question. As our world gets even more connected, more complex, and more data-driven, what limitations will we hit next? And what problem will the next great API tool be invented to solve?